All right, so in this problem, we're going to solve it just like we've solved the problems before, where we are going to use annotated art, formal representations, and some step-by-step solutions to get to our answer. So, you see a problem where baby Zach is splashing the water in a bathtub 12 times every 5 seconds. Gives you the distance of the bathtub, and it tells you how many waves you see at any given time in the tub. Ultimately, what we're trying to figure out is what is the wavelength, frequency, and period. So if you have a younger brother or sister or a cousin or some baby that you've seen in the bathtub and they keep splashing the water, they can be creating a lot of waves, but you don't see all of the waves at any given time. You just see some of the waves that they create, and there's reasons for that we'll learn in the course. So at any given time, we see 6 waves. From the left dot to the orange dot, left black dot to the orange dot, that is the length of one wave, which we call wavelength, lambda. And you see in this illustration that I've drawn, if you took that same wavelength and you took it forward, that there are 6 waves represented. We see the 6 waves at any one time, and the bathtub was 1.8 meters in length. Now, the equation for this that you see, there's no special equation. This is not an equation that you just memorize and use any given time. This is the type of solution that you reason through. We know the length of a bathtub. We know how many waves we happen to see in that bathtub. Well, if you divided the length of the bathtub by the number of waves you see, you would be able to tell the length of a single wave. So the wavelength ends up being 0.3 meters. That means that if you see 6 waves in the 1.8 meter bathtub, each one of those waves is 0.3 meters in length. Next, we want to figure out the frequency. We have, of course, the same information. To figure out the frequency, this is also something you can reason out. Baby Zach creating routine splashes in the bathtub, he is creating a wave pattern. And so the splashes he's creating every second are the same as creating waves per second. So when we think of frequency, we think of the units of waves per second. So frequency is waves per second. Oftentimes we will use the units of hertz to describe frequency, but hertz is just the name of an actual person. Waves per second is the actual conceptual unit, and it has some more meaning and is helpful for helping us reason through problems. So Zach is creating 12 splashes every second. Wave is a splash, so the frequency is 12 divided by 5, which is 2.4 splashes per second, or 2.4 hertz. We can use this frequency information in the next slide. So you see in the upper right that I've included that, because now we're solving for period. If that frequency is helpful, then we will use it. Remember, the period is the time from the beginning of one wave cycle to the beginning of the next wave cycle. So we've also learned that there's an equation for period that is 1 over the frequency. We know the frequency, so we substitute and we solve, and we get that the period of a wave cycle is 0.42 seconds. So every 0.42 seconds, another wave emerges. And that is the end of this show.